Looks like we're live. Hello everyone and welcome to yet another losing session. So let's make a little bit of an announcement and officially start the stream as usual. So today, what are we doing today on twitch.television website? That's a very good question. A red circle, not red car, red circle, live on Twitch. And today we are actually doing a very interesting thing. Today we are doing a review of a pull request, right? Something that I rarely do these days, that introduces next level OpenGL font rendering into the text editor that been developing for the past like several months. Actually, we've been developing for a couple of years, but it was postponed, so doesn't matter, right? So let me give the link to the twitch.tv/turning, the place where we do all of that, and ping everyone who's interested in being pinged. There we go. The stream has been officially started. Hello everyone. Welcome. So the text editor can be found in here on github.commercial website. So it's a very dramatic text editor. Right, so the name is basically abbreviation of that, dramatic editor, DED. Let's actually go there and take a look at the text editor, right, if I open it like that. So this is how it looks like when I start typing. It actually does the camera action, so it pans and zooms and stuff like that. So this is basically the text editor. It has a little bit of a highlighting, syntax highlighting and stuff like that. So today I received a very cool pull request, which I want to review on today's stream, because this pull request is extremely fascinating and it actually taught me a lot of new things. So I really want to share those things with everybody. So it was submitted by MadeH and it introduces the distance field font rendering. And if you take a look at the screenshots, the font rendering actually looks awesome. It's actually pretty good. Right, so, and I was wondering, like, how much code did you need to add to support this kind of level of font rendering? Because it's actually kind of cool. I want to have this kind of font rendering. And the amount of code you need is actually this. That is literally it. A couple of changes in how you load the fonts, right, and a little bit of a changes in the fragment shader. But it's not as simple as that, because if you take a look at the fragment shader, there's quite a lot of things going on in here. We use some sort of fwidth function and also like to compute a value, and we do smooth step by using that value in here, and it's just like, what the hell is going on and what is the fwidth? Right, so if you Google up, so this is definitely not a function that was defined somewhere here, and I never heard about this function before. So it's a built-in function in fwrite, so I have reflexes to write fwrite, fwidth, GLSL fwidth. If you take a look at this function, the description of this function doesn't help either. Right, so it returns the sum of the absolute value of derivatives in x and y. Wait a second, derivative of a function, so derivative of what? And it says that it's equivalent to this expression, basically the sum of derivative of x and y, but then if you look at these functions, it's a partial derivative of argument with respect to x and y, and it's just so confusing. There's like very little code, and it doesn't really tell you much. But it introduces like a pretty cool rendering. Right, so this is precisely what I want you to do today on today's stream, to actually get into what exactly going on in here, because it's actually kind of cool and it's kind of awesome what it's doing in here, and this is definitely something new, right? So I'm not a graphics person, right? I'm not a graphics person, so this kind of stuff is, you know, very unfamiliar for me, so that's why I'm so fascinated by this. If you're like a game engine developer, this is probably like old news for you, but I don't develop engines, right? So I'm a very dumb enterprise Java developer, so yeah. Anyway, so we've got a sub from Sinoyet. Thank you so much for tier 1 subscription. Thank you. Really appreciate it. So the first thing we want to do, we want to probably, download this change and actually compile it on our machine, right? So let's actually quickly do that. I want to grab the repo of Mate. I hope I pronounced your nickname correctly. Actually, not nickname. It's an actual name. Sorry. All right. Okay, so let's actually do the following thing. So we need to add the following thing in here. So I forgot how to add things. So I want to do something like this, and it's actually TE, but it has to be dead, right? So hopefully it will work. All right. And let me see. So here is actually the branch. It's actually not on top of the latest change, so maybe we'll have to rebase it a little bit, or at least merge it, because rebasing is a very much destructive operation, right? So it's better to merge this entire thing. And if we try to build this entire thing, what's going to happen? It is not going to build. It's a pretty interesting pull request, but it's not going to build. And why it is not going to build, and this is because it couldn't find this specific value, right? So if we try to search for this entire thing, like what the hell is that? So we can find the documentation for free type, right? And it's one of the ways to, I suppose, yeah, it's basically a render mod, right? So this mod corresponds to 8-bit single channel signed distance field bitmaps. Each pixel in SDF grid is the value from the pixel's position and to the nearest glyph outline. The distances are calculated from the center of the pixel and are positive if they're filled by the outline inside of the outline, and negative otherwise. Check the note below on how to convert output values to usable data. So the way we render the fonts right now, right, is that we render them using a bitmaps, just like a regular bitmaps. Right. So these bitmaps are created by free type library, and then we put them into the texture, and then we upload it on GPU, and in the shader we just like map the pixels. So apparently this new value that was added in the pull request renders the fonts in a completely different mode, right? Instead of pixels, like what is the brightness values that are usually put in there, that we usually use in our fragment shaders, there's a distance. Right, they're storing a distance to the outline, right? So, which is rather interesting. And if I understood correctly, let's take a look at this stuff. So we've got some subs from, yeah, so there was like a 5 gifted sub from Sinoet. Thank you so much for 5 gifted subs. Thank you. Right. So, essentially, I suppose there's some sort of an outline for the font, and each pixel is basically either inside of outside of the outline or inside of the outline, and basically the value that we store in a pixel is the distance to the closest outline. And if it's positive, if that distance is positive, it's actually inside of the outline, and if it's negative, that means it's outside. So you can use this information to know whether to color a certain pixels or not color certain pixels. But on top of that, if you know the distance, you can actually do different interesting effects, like maybe like an inner shadow, right? So if you want to do some sort of like an inner shadow, you can kind of easily do that, right? Because you know how close you are to a certain like edge in here. So for instance, if you're too close, you can just basically dim the pixels a little bit, right? You can basically dim the pixels. So that's kind of interesting. But what if right and partial derivatives of some functions have anything to do with all of that? That's another interesting thing. But on top of that, we can't even find that in our, in our library at all, right? So we can actually find that. So if I try to maybe grab it, so I have a free type in here, right? So grep rn, I can't find that. It simply doesn't exist. It simply doesn't exist, and this is part of the enumeration, right? This is part of the enumeration. It's a FT render mode. Right, it's an FT render mode, and if we take a look at the render mode, right, so, okay, let me see. So, why did it jump? God damn it. This website, I swear to God. Yeah, there we go. So, it literally doesn't exist in my version of free type. Apparently I have a too old of a version of a free type, right? So the version is too old. So I can't just use that. It's a very cool pull request. It's a very cool pull request. It adds a very cool feature, but I don't have a new enough free type library to actually use that. But as far as I know, the SDF support in free type was introduced like 2 years ago, right, if I'm not mistaken, so it's not that it's super new feature. But in any case, the first thing we'll probably have to do, we'll have to download the fresher version of free type library and build it from scratch. Right, this is something that we'll need to do first, so let's go and do that. And why did it redirect me to HTTP? Right, I have no idea why it redirects me to HTTP, because yeah, so it's better to use HTTPS, because for the HTTP websites, my government actually embeds some sort of propaganda. Yeah. They actually do that, right? So not on all the website, but some of the websites that don't have HTTPS, they basically embed some sort of propaganda into the HTML, like literally. So they cannot do that if you use HTTPS. Alright, so let's actually download the LX version. So we've got another sub from Step Sister Trap. Thank you so much for 7 months of tier 1 subscription with a message. Hello Zozik, how are you doing? I'm doing well, thank you. Alrighty, so let's go. So okay, so maybe I want to actually sort that by a name so I can find. That didn't help. Okay, that actually made it worse, because it actually moved all of the libraries down below, and they're not even sorted by their version. Who developed this website? So first comes 9, 8, 7, and oh my god, it's a lexicographical order, and it, oh, ooh, boy. Alright, we're off to a great start apparently. So I'm gonna, it's docs, it's not even what I need. Okay, I'm gonna assume that it's like 13, maybe free type Wikipedia. So Wikipedia usually have like the latest version written in there. It's like, dude, like what's the point of sorting the by name if you can't even handle the versions inside of the names? It's like the only reason why you would sort this specific column, you know what I mean? Okay, it's 13. Okay, so let's actually download the 13 version. Alright, so let me quickly do that. And I'm gonna do wget, and let's just get this entire thing. So while we're getting this entire thing, so we have another sub, the follower 07. Thank you so much for Twitch Prime subscription. Thank you. Really appreciate the subscription. Alright, so let's go. I'm gonna unpack this entire thing, and let's see what we have. So we have configure. So do we have anything special in here? So like different libraries and stuff like that, nothing particularly special. Okay, so I'm gonna do configure, and I'm gonna set the prefix to my local OPT folder. So this is gonna be home, OPT, So essentially, prefix basically tells the build system like where to install after the build, right? So quite often people think that to do configure, make, install, you need a root access. It's actually not true. You can actually install this kind of projects like anywhere. You just have to specify the prefix. We're gonna install it at home, opt, and I'm gonna actually install it into the folder with the corresponding name and the version. So that way, if I need like several versions of FreeType, I can easily do that. So let's actually do the configure and let's go. Okay, so we do external zlib, bz2, libpng, no broadly. I have no idea what is broadly. Is that something I need? Let's take a look. So this is broadly compression format by Google. Okay, I already lost interest. Cool. So let's actually go ahead and build this entire thing. So do I want to do 5 threads? I'm a little bit scared that if I do 5 threads, like it's gonna like stall the entire, you know, the entire stream. So let's actually use 2 threads, right? So we're gonna do 2 threads in here. Just a second, we've got another sub. Ranzel117, thank you so much for tier 1 subscription. Thank you with the message hello, my comrade, how are you doing? Hello. Negative attention span. No, this is not because of my attention span, but this is because it's Google. That's why I lost interest. Have you seen the latest presentation by Google with their like AI? Google is not cool anymore. Like, I mean, who gives a fuck about this boomer company? Damn. It's all about Microsoft these days. Fucking no, I don't care. I don't care about any of them actually. Okay, good. So I'm gonna actually do it like that. I'm pretty sure the compression is actually very bad. Gonna try to compile Gento again. As far as I know, FreeType is not that big of a library, and it's already linking. Is it linking? I think it is linking. No, it's still compiling. Whatever. Okay, that is it actually. So this is the entirety of the build, and let's install this Motherflipper. The Motherflipper has been successfully installed. So if we take a look at what we've got, Yesu, kawaii freaking death. So we've got 3 folders in here, right? So here's the include, and here's the ft to build, and the only thing I care about, does this thing have the option render mode SDF? So that's the only thing I care about right now. Yes, it does. Look at that. So it mentions that in the source code, and here it is. This is precisely what we need. Absolutely freaking beautiful. Okay, so what else do we have? We have libraries, right? So we have some different libraries, static and dynamic, and most importantly, we have a package config, right? So package config is going to be super useful because it basically allows us to configure the build to use this specific library, right? Essentially, what I can say, I can do package config, and I can say, okay, FreeType 2. So what kind of C flags should I put into my command line to actually build with this library? And it's C flags, and it gives us these things. So basically it gives the path to the include folders where you have headers and stuff like that. And then I could say, okay, what should I link this shit with? And it gives us -l FreeType, right? So, and the package config, like PC file description, basically contains the information for the package config utility, right? And this is something that we will need to configure things properly, more or less. Right, so what else do we have in here? We also have share. It includes AC, some M4 macros. I'm not sure what it is, and I'm not sure if I care. So the library is actually relatively small by itself. So the only thing we care about here is probably include and library, right? But the problem is that we can't just use that, right? So as you can see, in the build, in the build, we're still using the old locations for the free type, right? So I'm using the system one, but I need to use the one in my home folder. Right, so as far as I know, package config utility has like a search path environment variable. Search path environment variable. All right. Package config path, I think this is precisely what we need in here, package config path. So let's go and just do the following thing. So package config free type to C flags. And then I'm gonna say package config path, and I'm gonna redirect to the free type folder. Right, free type 2, then the thing is located in lib package config. Right, it's kind of difficult to see anything in here because it's closed by my webcam, but if I move things around like that, you should be able to see some stuff on here. As you can see, I set environment variable to this. Maybe it would make sense to actually do it like this. Yeah, there we go. Okay, and if I do it like that, okay, so it's using the new paths in here. So this is probably what we want to do in here. Right, so let me actually copy paste this entire thing. I'm gonna just select it very carefully and go to the build, actually sh, right? So, and here I'm going to just insert this thing in here. So it expanded the environment variable home, so maybe because of that I want to do something like opt. Yeah, there we go, home. So that should probably work. Let's try to build this now. Does it use the new? It's still using the old one. Probably because I have to export the entire thing, right? So I have to export the entire thing, and now it's using the new paths, which is nice. And I suppose it should use it also gives the link paths as well via -l and stuff like that. All right. So what else do we have in here? So so this basically built everything already. Let's try to run it, and it doesn't. Oh yeah, I think I know what exactly is going on in here. I think I know precisely why it is happening like that. Because even though we linked it with the new library, right? Even though we linked it with the new library, it's still using the system one, right? It is still using the system one. So we have to probably use something like LD library path. I think that's what it is. LD library path to tell this thing how to properly run. Right, so LD library path, and we have to redirect this entire thing to here. Right, free type to lib, right, and this is going to be like this. And okay, so we managed to run that. We actually managed to run that, which is kind of cool. And yeah, isn't that cool? Isn't that cool, everyone? I think it's pretty freaking cool. So now we have like a smooth rendering, which is actually kind of cool. Right. So that's actually way better, right? That's very nice. I could have actually just merged this entire thing, but I don't like to do that. I want to understand how exactly this entire thing works, because if it's only just 3 lines, but I'm not gonna merge just some sort of like a magical 3 lines that I don't know how to use, how to extend, and what to do with them. So for me, it is quite important to understand what the fuck is going on in here and why we do this thing this way. Like, why do we need to do smooth step in here? What is f width? What the fuck is all of that? Why? It doesn't make any fucking sense. I mean, the result is cool, but the entire thing by itself doesn't make any sense to me. So that's why I need to understand what the hell is going on in here. Right. So let's go and play with the shader, right? So because it's just a shader change, so that means we can go and Right. So I guess somebody forgot to port the shader to another shader, right? So because the text that is rendered by like for the text editor and for the file viewer are two different shaders. So for the file viewer, it is rendered by this separate shader, and it was not ported there. So the author of this change didn't check how it works in a file browser. So, but we can actually port that very easily. So what do we have in here? So we are extracting the value of the current pixel, right? We are extracting the value of the current pixel, and then we transforming it several times until we get some sort of alpha, right? So as you can see, we take D, then we transform D into AAF, whatever that means. Then AAF gets transformed into the alpha, and then alpha is used as the alpha for the color. So what if we cut middleman, right? What if we cut middleman and say, okay, just use D directly, right? So we can take whatever is stored in the pixels and let's just take a look how the pixel looks like. Right, I'm gonna save this entire thing and I'm gonna refresh, and this is how it looks like if we don't do these two lines, right? So there's a little bit of like transformation. So we take the value of the pixel, we transform it around, and we then use it as an alpha. If we don't do that, this is what we get, right? If we can take a look at this entire thing a little bit closer, right? So this is how those things look like. And as we already know, this is basically SDF. Right, so it's a signed distant field, right? It's a signed distant field, and each pixel stores the distance to the closest outline, right? The distance to the closest outline. And essentially the outline is somewhere around here, right? It is somewhere around here. And the thing that fades away in here is basically, it shows us that the closest distance is in that direction somewhere, right? As you go further and further away from outline, it becomes fainter and fainter and fainter, right? So that's basically what it is, which is actually makes sense, and it actually explains why it looks blurry in here, right? Because we just don't do these transformations for the epic shader, right? That sort of gets away the blur, if that makes any sense, right? So we basically, these two transformations just basically remove the blur. If we just do it like that and we save it, and there we go. So there's no blur anymore, and it's like actually very crisp, and actually feels really satisfying when you make it finally crisp. So that's pretty cool. All right, very interesting. So the fact that this entire thing works, by the way, the fact that this works without producing any artifacts, right, means that the value of D is from 0 to 1, right? The value of D is from 0 to 1. But if we take a look at the description of the render option, right? The description of the render option, I wish I could find that. So let me take the render option, put it in here. So the mode corresponds to 8-bit single channel signed distance, right? So it's signed. The distances are calculated from center of the pixel and are positive if they're filled by the outline and negative otherwise. So essentially, if the pixel is inside of the shape, it has to be positive. If it's outside, it has to be negative. But the fact that this just works means it's from 0 to 1, which is like, why is it not negative? Right? I'm pretty sure if I put something negative in here, it would have some weird really artifacts, but like, why does it work if free type returns us a bunch of things that could be also negative? That doesn't make any sense to me, don't you think? That's kind of weird. So one of the things I want to do, I want to take a look at what exactly free type returns to us. What the hell does it return? Like, I just want to see that, and then we take that, whatever it returns, and pass it to OpenGL, right? And OpenGL can also transform it, right? So OpenGL has a tendency of transforming things around for you. So let's take a look at what we have in here. So I think it's a free type glyph, blah blah blah. So here we're just loading a bunch of things. So here I'm just basically computing the size of the atlas. So essentially I pre-render all of the glyphs that we may need, and I put them into a single texture, and I upload to GPU a single texture. So and here I just compute the width that is needed, that I need to allocate for the texture. And after I computed all the width, I create the texture with the corresponding side, and I go through the glyphs yet again, actually rendering them. So that means that in this specific loop, I have this thing which points at the beginning of the buffer containing the pixels. Right, so this is the pointer that we need, right? So this thing points at the beginning of the pixels. We need to print them just to see what's going on in here. So, but we need to maybe, let me think how I want to do that. So I think I could just pick a random glyph, and when I encounter that glyph, I'm gonna print the values of the pixels, and I'm gonna crash the entire thing so I can see what exactly in that glyph. But 32 is a space, so it doesn't really have any pixels, right? It doesn't have any pixels, so we need to maybe pick 33 or something else, right? So, but I don't remember what is 33. Right, so if we take a look at the value in here, so it's an exclamation mark. I think exclamation mark is actually pretty good glyph to take a look at. Right, so let's do the following thing. If the glyph is 33, let's try to render this entire thing. So we need to know the width and height of this entire thing. So we have rows and width. So I suppose these are the things that we'll need in here. So let me quickly maybe copy paste this entire stuff. So this is just like a scratch pad, right? This is not the code that I'm going to be actually using, but I'm going to be copy pasting stuff from here, right? So I'm starting to iterate the rows, right? From 0 to this. I'm iterating all of the rows of this entire thing, and then I'm going to be iterating all of the columns of this entire thing. Right, so let's take a look. So, cool. And now, since this is a pointer, right, and it's a pointer to the beginning of the two-dimensional arrays, so that means we have to, you know, do the following thing, where we take a row and multiply by the size of the row, which is width, right? So we skip certain amount of rows, and then we offset by the column, and that gives us the pixel. Right, so if I remember correctly, they're signed or not signed, but I'm gonna just basically cast it right away into an integer, and I'm gonna print it as a signed integer, like so, separating by space. Okay, so this is the first row, and then I'm gonna print a new line. Let me comment out this stuff, it's not needed, and then I'm gonna crash the entire thing, right, because I want to display what we've got in there. Okay, so let me just build the entire thing. So there's sinus, so I suppose the width and height are unsigned, so that means I have to use something like size t in here, so it doesn't complain, if you know what I mean. So it doesn't complain. So now if we try to run this entire thing, oh, okay, so I need to provide the LD library path. So I have an idea. What if I do the following thing? What if I do export LD library path, and I specify literally the same thing actually, right? And then in here, after I build the text editor, I also run it as well. Right, so then I can just do build.sh, and it will build it and automatically run it for me. Okay, we got something. So this is the glyph, I suppose, but unfortunately some of the values are like have 1 digit or 2 digits, and it's not aligned. It's really difficult to see something in here. But one thing we can instantly see is that there is no negative values in here. So it said that it's like, if it's outside of the shape, it's negative, and if it's inside of the shape, it's positive. But we don't have any negative in here, which is, I mean, explains why in OpenGL we didn't have anything negative, but it doesn't explain why the documentation is talking about negative values. Anyway, let's actually try to pad the things with zeros just to see like how the entire thing looks like. So I can do something like, I think this is how we do that with integers, right? So that should work. So that should work as well. Okay, and that looks pretty good. And this is exclamation mark, right? So this is straight up exclamation mark. Explanation mark. Explanation mark, not exclamation mark, but explanation mark. All right, so, and you know, I think it will be kind of cool if we just skipped the zeros, right? So if c is equal to 0, right, instead of like printing that, just print 1, 2, 3, 4 spaces. I think that would be actually kind of cool, and we'll see the entirety, like the entire shape of the glyph in here. Right, so the entire shape. Let's take a look at the shape. Okay. So does this look like exclamation mark? I think it does. It's actually kind of cool. What the fuck? All right. So that's very cool. So this is the glyph that we got out of the library, and each pixel in here is basically the distance to the closest outline of the shape. Right. So anyway, the question is like, what the fuck is wrong? Like, where are the negative values, right? So, so essentially, there is a note about how the values, how the distances are stored within the pixels, right? The selector render mode, blah blah blah, whatever. For SDF, the output bitmap buffer contains normalized distances that are packed into unsigned 8-bit values. Right, so even though the values are signed, they could be negative. They are stored in unsigned 8-bit values, normalized, whatever that means. To get pixel values in floating point representation, use the following pseudo C code for the conversion. So, and what we're doing here, we take the pixel and we subtract 128. So yeah, so essentially, if we take a look at the values of the pixels, like what are the minimum value? The minimum value is obviously it's obviously 0, but the maximum value. So the values are going to up to like 190, right? They go up to 190, which essentially means that they are using the 8th bit, right? So essentially, because of how these things are stored, they could be treated as values from 0 to 1, right? So essentially, the values from minus, oh my god, I can't, minus 127, I think, to 28, I don't remember if it's 28.7 or 27.8, I can never remember. Right, they're stored as values from 0 to 255, right? So essentially they store values from 0 to 255, but they tell you interpret that as this range by subtracting 128 or something like that, right? So again, I might be wrong in here, I don't remember like on which side we just remove 1, but it doesn't really matter that much, right? So essentially, if you don't want to do this kind of thing, so it's probably 28, 27, okay, whatever. So if we don't want to do this conversion, we can basically treat the following thing as following, right? Everything below 128 is outside, everything above 128 is inside, right? So essentially you can treat it as the documentation says, or you can just treat it like that, right? So, and then we pass this stuff to OpenGL, and OpenGL converts this entire stuff to 0, 1, which means that inside of the OpenGL shader, the threshold for the outline is 0.5. So essentially, inside of the shader, if the value is less than 0.5, that means it's outside, of the shape. If it's greater than 0.5, that means it's inside, right? Because of this like weird conversion and representation and stuff like that, it's kind of like unclear. It was unclear for me, at least, like how does this work. But if you look through the documentation and just logically analyze everything, it kind of makes sense, right? So the threshold is 0.5. So let's actually try to confirm that. So let's run the editor. So I probably need to actually remove the code that crashes the editor super quick. It actually started to load slowly. I wonder why. Maybe it takes some time to generate those distance maps or something. I'm not pretty sure. Okay, so let's go. Okay, so everything is very blurry. I really apologize for that. So let's go to the text. So to get rid of the blurriness, we're gonna do the alpha. Right, I'm gonna save that, and there we go. So to confirm this entire stuff, right, so first of all, I'm going to just... Ooh, it's actually kind of dangerous, right? What if I put 1 in here? Yeah, so now I can't see shit in this mess. But I can actually try to type blindly. Yeah, so I can actually type blindly. Right, so what we can say, if distance is less than 5, basically put nothing in there. GL frag color. So we can just do something like this, right? So otherwise, put something in there, right? I'm gonna put simply 1, 2, 3, 4. And I'm gonna refresh this entire thing, and it worked, but it actually removed anti-aliasing. Now everything is very pixelated, but it confirms that it is in fact true. What's interesting is that, can we make it like a different threshold? What if I use this threshold? Yeah, it becomes thicker essentially. So that confirms this entire theory, right? So it becomes thicker and thicker and thicker. So yeah, that's pretty cool. If we make it bigger, it becomes thinner, so we can actually control this kind of stuff. That's actually pretty cool. Right, so that means that this entire code has probably something to do with anti-aliasing, right? Since the distances are very smooth values, you can actually use that information to smooth out the edges. And in fact, this is probably what AA actually means, and I think it was actually mentioned in the pull request itself. That it has something to do with the anti-aliasing, right? Sort of like anti-aliasing. Yeah. Ooh, yeah. Text with the anti-aliasing. Okay, so that's pretty cool. So, and this is probably what 0.5 actually means. It probably means the threshold of like being inside or outside of the outline. And essentially what we're doing here, so D is a value from 0 to 1, right? So, and okay, so what essentially we're doing in here, we're taking that threshold, we padding it from both of the sides, from left and from the right, and then we're doing a smooth step between them. Huh. That's actually pretty cool. So essentially, let me show you. Right. So here is the sort of the range of the distance, and at 0.5 we have a threshold. So everything below that threshold is outside, everything above is inside. Essentially, by adding a little bit of a padding, right? So pad here, and maybe minus pad here. So I wonder how can I represent that a little bit better. Right. So we are checking, right, whether the D is between these things, and if D is below this entire stuff, we automatically make it 0. And if it's above this thing, we automatically make it 1. right? So that way we sort of implement it's like a simple anti-aliasing, like a very simple anti-aliasing where we just define a certain sort of like width of the fading out, right? So, and but the question is, what the hell does it have to do with this weird function, like f width or something like that? Can we just like pick a random sort of like a padding for this entire thing? Right? Can we just like pick a random? Like, what if I say, okay, so I'm gonna pick like something like 1. Can I do it like that? So yeah, I probably have to actually get rid of the entire thing. Right, so let's actually... I can't remove this selection, god damn it. So maybe this is something I have to implement at some point, but yeah, that essentially means that I have to do that manually. So also want to remove that. And here we have to use alpha, right? So here I have to use alpha. Right, and I'm gonna refresh that. And it kind of works. So what if I make it like a little bit bigger? It becomes blurrier. Okay. Okay, so I think now we know what this parameter kind of does. It just basically increases that specific padding, right? So that means we can make it blurrier and blurrier as we go, right? Until it becomes like 0 and... No, it's not 0, it's actually 1. It becomes 1 and it's like this. I think we can even keep making it bigger. Right, yeah, it will become even more blurry. It's so blurry that it goes outside of the boundary box of the glyphs. Right, so and it's basically a question of picking up the right distance, right? Picking up the right distance. But why using f width, which is derivative of something, is the perfect sort of like, you know, width of the anti-aliasing? Like, what is that? What is this f width and what the fuck is going on? GLSL f width. Well, I mean, we know that f width from the documentation of f width itself is basically the sum of the absolute values of the partial derivatives. And what is a partial derivative? Partial derivative of what? So what I like about this documentation is that it's talking about partial derivative of something, but it never specifies partial derivative of what. Because when we talk about derivatives, we're talking about derivatives of function, right? So what function? Like, what the fuck are you talking about? This is just so weird. But if you Google it up, it actually kind of makes sense. There is like a bunch of explanations on the internet. I'm pretty sure ChatGPT can also explain you that as well. GLSL DFDX. All right, so let's actually go ahead and do that. Explanation of DFDX on Stack Overflow. All right, so let's take a look at this entire thing. To understand how these instructions work, it helps to understand the basic execution architecture of GPUs and how fragment programs map to the architecture. GPUs ran a bunch of threads in a lockstep over the same program, which each thread having its own set of registers. So it fetches an instruction that then executes that instruction n times once for each running thread. To deal with conditional... okay, I don't think it's that important. I don't think this thing like is relevant to what we're doing. Now, when a fragment program is run, the fragments to be run are arranged into quads 2x2 squares of 4 pixels that always run together in a thread group. Each thread in the group knows its own pixel coordinate and can easily find the coordinate of the adjacent pixels in the quad by flipping the lowest bits, blah blah blah, and stuff like that. So here is an interesting thing. DFDX and DFDY is basically the difference between these neighboring pixels. That's it. Believe it or not, it's like a difference between the values of these pixels. So when in a shader you take in derivative of a certain value, right? So the value D, this is the value that is computed per pixel. Right, this is a value that computed for each individual pixel, and since the GPU knows like a neighboring pixels, it can find a difference between them and tell you how quickly this value changes and in what direction it changes, because that's what derivative is. It's a change of a certain function, and it can do that vertically and horizontally. And since it does that anyway, it can give that information to you. Right, it can just give you that information, right? And if width just sums up the change by x and change by y, it just sums them up. And since it's neighboring pixels, it means that it's going to be a perfect padding for your anti-aliasing regardless of the zoom, right? So it's going to be regardless of the zoom. So at least this is how I understand that. At least this is how I understand that. Like, but this is actually so interesting. Like, I would never stumble upon this kind of stuff unless somebody would show that to me, right? Actually, like, I received this pull request at morning this day, so today is evening, and I spent like half of a day actually researching all of that and trying to understand what the fuck is going on in here, because I really like this kind of stuff where it's literally 3 lines. But it took me like half of a day to learn and decode these 3 lines to understand why it is done like this. And this is so cool, and I really want to thank the author of this pull request, because they just taught me so much new things with just 3 lines of code. I really appreciate shit like that. Thank you so much. Thank you. Holy fuck, this was so fucking cool. And yeah, I heard about SDFs before, but I never seen how they're used like in practice, right? And I've never heard about f-width, and I've never heard about like these derivatives and these like, you know, rate of change, and that you can use this kind of thing. It's just like so fucking cool. So yeah, and it makes so much sense. I hope I managed to explain that in an approachable way, because I do not fully understand it still myself, but this is how I understood it. If I made any mistakes in my explanation, please let me know. But yeah, so this is actually very freaking cool. Thank you so much. Yeah, people say it's common in game dev graphics programming, I think. Yeah, so I'm not a game dev developer. Right, but I'm not a game developer, so I'm not really that familiar with these kind of things. So yeah, that's pretty cool, and it actually yields a very cool results. Right, thank you so much. We're gonna merge that soon, but first, what we need to do, we need to port that shader to the file browser as well. Right, we need to port that to file browser as well, because as you can see, it's very blurry. But now we know why the fuck it is blurry. Now we know that because it's just using the value of the pixel directly, which is just the distance, and it doesn't really do the same thing, right? It doesn't really do the same thing. But what's funny is that we don't really have to copy paste that shader, right, to re-implement it in here. Since we understand how it works, we can just, like, you know, implement it. Right, let's try to do the same thing. So first thing we need to do, we need to take the distance, which is basically located in this texture thingy, at R or at X, right? But I think we can use R. Right, then we have to find the rate of change, right? So it's going to be an anti-aliasing, you know, thing, and we just do f-width, and we basically know that this is just the anti-aliasing padding, right? This is anti-aliasing padding that we can use in a smooth step to compute the alpha, right? So, and we do smooth step. So we know that the threshold is 0.5, so we subtract the padding in here, and then add a padding in here, and there you go. We've got this entire thing, and now we can just use this alpha in here, so we multiply it by a rainbow. I suppose we can do vec4. We can do vec4 rainbow RGB, and it's gonna be alpha. Alrighty, so let me actually do the thing, and oh, and it also crashes. Didn't I fix that? Oh yeah, so this pull request doesn't use the latest changes, right? So it doesn't use the latest changes where we don't crash the entire thing. We don't crash the entire thing when we cannot compile the shader. So let me actually quickly merge everything, right? So let's actually, let me actually quickly merge everything. I'm gonna go here. I think I need to also create a separate branch in here. So I'm gonna merge without any fast forwarding with the master. Right, there we go. I hope it went well. Yeah, so essentially what we did, I merged master into the matter edge. Okay, so that makes sense. And now I'm gonna go here. Where are my stashes? So I'm popping the stash. There we go. So here I can just do it like this. Did I use F right instead of F width? God fucking damn it. Okay, I'm gonna just see. It looks exactly like F right. Like, oh my god. So let's do shader. So epic. F right. Oh, that's what the chat was talking about. Don't forget to F close. Yeah. God damn it. F width. Sure. Anyway. Don't laugh at me. Right. Streaming is hard. And look at that. Holy fuck. That is so freaking crisp. I'm not sure how well it is translated via the stream, but it's so fucking crisp. It's so fucking cool. I really like that. Thank you so much for this change. That is so freaking cool. Yes, yes, yes. And it just like feels so much better. My god. So, and especially like when it's too like very close, right? So because it automatically just scales properly because it's a vector graphic essentially. It's a vector graphics. Vector graphics. Yeah. Hello. Look at that. Look at that. Zoom in. Oh my god. It's so fucking good. It's so fucking crisp. So we can try to compare that with some other things. But first, let's do a committee. Port the AA shader to let's put it this way, port AA to the epic shader, right? And I'm gonna go to the master and I'm gonna rebuild this entire thing. So we're gonna be using the previous thing, and we can even compare them. Right, does it still use? Yeah. Oh my god, it doesn't even feel that crisp anymore. Look at that shit. Oh my god, it's even bleeding between them. So the use of SDF actually fixed a very annoying thing for me. It doesn't bleed anymore. And also, you can clearly see that it was like very staircasey, but then on top of being staircasey, it was kind of like linearly interpolated, but you still see the staircases within here. And it's just like, oh my god, this is so bad. But I didn't want to spend too much time on this kind of things because I needed to develop other features. So, and it stayed like that. But now it is fixed. Now it's much better. Thank you so much. All right, so let me go here and I'm gonna restart the entire thing. And now it's much better. No bleeding. No weird stairs within the stairs or anything like that. It's just like smooth. Freaking perfect. Okay. Alrighty, so let's actually do the following thing. So do I want to commit these things? So this is like purely for my setup, right? Because I'm using like a shady old Debian stable. I'm pretty sure this is not going to be the thing for the majority of people, right? So, and also I think it makes sense to document whatever we have already, right? Because this is not going to work with all of the versions of FreeType, right? But it's interesting, it's like, what's the minimum versions of FreeType that it would work on, right? But it will take too much time for me to investigate in the stream. So we got a bunch of subs, I suppose. Actually, one. Renew Roxai, thank you so much for 24 months of tier 1 subscription. Thank you with the message. Hello, my comrade, hello. how are you doing? Really glad to see you, my comrade. Cheers, bye. Getting into graphics libraries seems like such a deep rabbit hole. Yes, it does, actually. It actually does. But it could be fun for some people. It's definitely fun for me. Alrighty, so what I want to do, I kind of want to document the dependencies, right? Dependencies. So the two main dependencies that we have in here are SDL2 and FreeType, at least right now. In the future, I plan to, well, I mean, also OpenGL and stuff like that. Glue as well. God damn it. Too many dependencies. I also plan to use HarvBus, but FreeType 2 already kind of uses HarvBus under the hood, right? At least this is what I saw in the configuration. If you try to do configure one more time, right? So it's talking about HarvBus, right? So if I reconfigure the FreeType, it is actually referring to HarvBus already. So that means it's using it internally, and I wonder, since it's using it internally, right, do I need to use it directly? Which is a rather interesting question. Maybe it will just like fix everything for me. Right, we'll need to investigate that. So we got a bunch of more subs. Actually, another one. Matthews, I hope I pronounced your name correctly. Thank you so much for Twitch Prime. Thank you. Really appreciate that, my comrade. Very appreciate that. Using dependencies indirectly doesn't sound like a good idea. No, I don't mean using HarvBus just because FreeType uses it. I mean use FreeType, just use FreeType and hope that it actually solves the same problem as HarvBus, but by using HarvBus. You know what I mean? Right, so because HarvBus is usually used for what? For you know, directional writing, like for languages from that write from right to left, also for polyphony writing that is very common in things like Arabic script and stuff like that. So if FreeType can do that for us, whether it's using HarvBus under the hood or not, I think we can be okay with that, right? So HarvBus is about laying out a string text versus single glyph. It would help with generating ligature and stuff like that. Oh, also ligature, thank you so much. But I mean, aren't ligatures basically rewriting, right? It's like in Arabic script, like glyph rewriting, but it's also kind of like ligatures, right? Maybe. I'm not really familiar with fonts and stuff like that, so I'm only learning all that. But yeah. Alright, so what do we have? So I wanted to document some stuff, right? So I wanted to document the dependencies, right? SDL2. So, but what's the version? How can I know the version of my SDL? libsdl. So let's take a look. The version full text search. So it's just 204, right? This is 209, right? So I know that it works at least with that version, right? Then FreeType 2.13.0 plus. It can probably work with a version lower than that, but I don't know the minimal version, right? So I can probably do some binary search after the stream, right? Because I know the version that is used on my machine, and I know that it doesn't work with that version, and this is the latest one. I can just like do a little bit of a binary search and find the, where it was introduced, essentially. Right, it would probably make sense to give the links to all of these things, right? So SDL2. Oh, by the way, have you guys heard that the developers of SDL also work on SDL3 or something like that, maybe? Or something, but I remember seeing a weird repo where they were doing experiments with an SDL shader language, right? Because one of the problems with SDL is that everyone just using it as the OpenGL initializer, and because it doesn't really have its own shader language, so in that regard it's kind of useless. unless the only thing you want to do is like rectangles or something like that. I wonder where it's actually going. So it's really early, I see. Okay, so there is like a labels for third versions on GitHub repo. Okay, very well then. SDL is just a fancy OpenGL initializer. Change my mind. I'm joking, but it actually has more things than just initializing OpenGL, because it can work with different inputs, it can work with sound and stuff like that. So it can actually do a little bit more than that. So yeah, what I want you to do, I just want you to give the link to this thing, right? So download this shit from here. And regarding free type, let's grab this thing from here. So this is where you can find, and we're also using glue, but I don't remember which, like, what's the minimum glue I can use, but I'm not sure if it matters that much. So the latest one to, but I can always just also check the lib glue in here, like in here. And it's basically 2.1, and it's the latest one. So when was the last time it released? In 7? Okay, that makes sense. I mean, I suppose they basically stopped developing this library, but I mean, that's better for me. I can now say 2.0 plus. I feel like this plus is kind of unnecessary considering the rate of development of this library, but anyway. So these are the dependencies essentially, right? And I kind of want you to document that. All right, so document some dependencies. And what I'm gonna do, I'm gonna push that right into their repo, right? So essentially, I'm not gonna make them make these changes if I can make them myself, right? So, so there is this thing that people during the review ask, you know, the authors of the pull requests to make small minor changes. But what I found is that if you found like a very small minor change that you can fix yourself, I think it's better to just fix it yourself and push into their repo like that. It probably depends. I think majority of people would be okay with that. Right. Usually it makes sense to ask the author of the library to, you know, do the changes when the changes are significant enough and you can just like quickly fix it yourself. But in here, I can actually quickly fix it myself, and the continuous evaluation is actually failing. But I'm not really sure if I give a shit. That's the problem. Do I give a shit? Oh yeah, it is using... Yeah. So, okay. So let's do the trick. Let's do an epic trick. Don't repeat that at home. Looks good to me. Thank you for your contribution. I'll fix the CI later, Kappa. Don't repeat that at your work. Don't repeat that at your work. I am a trained professional. I know what the fuck I'm doing. Right, so I know how to handle these kind of situations. You don't repeat that at your work. All right, confirm the image. There you go. That's very cool. So now it's available to everyone. It's available to everyone. Thank you so much. This is really, really cool. I really appreciate this pull request because these simple 3 lines of code actually taught me a lot of new things that I didn't know before. Just like I had no idea about this kind of stuff, and now I know. Thank you. That is very freaking cool. Very freaking cool.